Thank you for the introduction. I have a PhD. I'm not professor. I am not sure I will be professor, but I am very fine with the PhD degree. Thank you. So thank you again for inviting me. It was a pleasure to be here again. If we see a cell, we know that the size is about 40 micrometer. It contains a nucleus with a 10 micrometer, and that 10 micrometer contains 1.8 meters like DNA like that. It is packaged. We know that there are about 25,000 genes encoded on the DNA. If you look at the molecular structure of the cell, it's very precise, very targeted, very well designed. In one single cell, there are 100 trillion molecules. We know that this is a map of the chemical reaction. Roughly 2,000 biochemical reactions are in one single cell. And every second, there is 1 billion chemical reactions. We know that this is a cell cycle. So the cells are staying in a G1 genome phase. And when they decide to move to the S phase, then they duplicate the DNA, package the DNA into the chromosome, disrupt the original structure of the cell, then close the G1 and the mitosis, and build up again the cell structure. So the question is, how can organize that extremely complex process, the cell? What is the mechanism? And the question is whether it can be on a molecular level. Our statement is the life is not organized on a molecular level. It is organized on a submolecular level. And in the next 40 minutes, I'm going to speak about this submolecular regulatory system. But we know that there are two stable hydrogens. The ratio between the hydrogen and deuterium is 6,600 to 1. There is a big difference between the vibrational frequency of the OH and OD bond because the 100% mass difference between the hydrogen and deuterium. So when you are drinking a glass of water, you are drinking 3 different water molecules, H2O, HDO, and very low amount is D2O. That ratio means that out of 1 million hydrogen, there is 150 deuterium atoms. The heavy water, the deuterium was discovered almost 100 years ago, and after that, for 60 years, everybody used the heavy water. And it was proved that the water, deuterium in extremely high concentration, caused very significant changes in the living organism. So you can kill a dog with a heavy water 35%. And the reason is that these H bonds match much faster, 10 much faster than the D bonds. So it is called isotopic effects. The literature is huge. You are MDs, and you know that the calcium in our blood is about 2.5 millimole, magnesium 1 millimole, potassium over 4 millimole. That here is this 150 ppm means the deuterium level is 13 millimole. And that was ignored. Nobody investigated the possible role of deuterium in the living organism. So this is what we started to investigate. And the question is whether billions of years the deuterium has any role in the living organism. We published our very first paper 30 years ago. And we published these results. We checked the cell growth in vitro. So we prepared media with the normal water, with 30 ppm deuterium depleted water, 300 and 600 ppm deuterium enriched water. And this is what we found, that the cell growth was inhibited in deuterium depleted media, but it was stimulated at 300 and 600 ppm. We also published in that paper a mice experiment. So we transplanted the mice with a human breast cancer, and the treated mice consumed deuterium depleted water. At the beginning, we have 17 mice with tumor. 3 months later, we have 11 healthy mice. In the control group, 1 mice survived that 3-month study. Later, the technology developed, so we had a new technology to follow the cell growth. And here we produced media with a lowering D concentration. And as you see, the lower was the D level, the lower was the growth rate. And when we slightly again increase the deconcentration, the 200, 300, 500 stimulated cell growth. That technology allows us to see how sensitive the system. So in that experiment, we changed the media with 0 ppm, 1, 2.5, and 5 ppm every 8 hours. And as you see, the green light is different from the red light, which means that the cells recognized there's a lowering D level, and that modified the growth rate of the cells. How can we explain these results, and how did we explain it 30 years ago? At that time, in the 80s, at the 80s, it was clear and accepted that when a growth hormone binds to the membrane, that stimulates the sodium-hydrogen transport system that causes a pH increase in the cell, and this is somehow a signal for the cell to multiply. That paper was published in the Nature. In that paper, they wrote that they isolated the hydrogen ATPase gene from the yeast. They put it into the animal cell line. They could prove the active ATPase in the membrane. They could prove the pH increase, so that transport was activated. But everybody was surprised that cell line caused tumor in nude mice. How is it possible that now we are knowing a couple of hundred oncogenes, and we are searching for thousands of mutations, and here's an ATPase gene putting into the animal cell line, and that causes cancer? So we explained this. When a growth hormone binds to the membrane, and that activates the sodium-hydrogen transport system, that will discriminate and only transport the hydrogen. And immediately, the DH ratio is increasing in the cell. And we said, this is the signal. So when we apply deuterium-depleted water, that cells are not able to lift up the DH ratio to the threshold, and this is the reason that we can disturb the metabolism of the cell. This is the next, yeah. That would be the explanation that using deuterium-depleted water, this is a consequence. So, independently from our research, there was published a paper that the hydrogen ATPase do not accept deuterium as a substrate. So it can occur that an enzyme is so sophisticated that it is picky. They catch the hydrogen but not the deuterium. And we made another experiment checking the sodium-hydrogen transport system. So when we acidify the cell pH inside, and we checked how the cells can recover the pH, it was different in the normal ppm and the deuterium-depleted media, suggesting that it can be real that the DH ratio is changing when there is the activation of the hydrogen transport system. So we concluded in our first paper that that would be the signal to start the cell multiplication or higher DH ratio. Albert Szent-Györgyi said that you cannot regulate the traffic with one light. You need another light. So if the cell membrane gives the green light, where is the red light? The red light is the mitochondria. Because when we eat the food and we burn the food to carbon dioxide and metabolic water, that is deuterium depleted. Everybody in that room produced every day 0.3, 0.4 liter deuterium depleted metabolic water. Because from 100 gram fat, we can produce 107 grams water, from carbohydrate 56 grams water, and from proteins 40 grams water. This is what we are synthesizing every day. And in that water, the hydrogen is coming from the carbon. What is the deconcentration of these different foods? So when we are eating food, our mitochondria will produce water with 150 ppm as a normal water. But the more fat we eat, the lower will be the deconcentration of the metabolic water. So the final deconcentration what the mitochondria can synthesize, it depends on your diet. A calorie intake is covered by carbohydrate or covered by lipid, or what is the ratio between that two main carbon sources. So the basic situation is that in a healthy cells, the membrane transport is working and is going and able to increase the DH ratio. But in a healthy cells, the mitochondria are working properly, and they are producing deuterium-depleted metabolic water. So the DH ratio is relatively low. And we know that there is one common feature in each cancer cells, the damaged mitochondria. So in the cancer cells, no deuterium depleted metabolic water production. It means at the beginning, and this is normally the DH ratio is higher. It doesn't mean that that cell will multiply, but the probability that the cells can enter to the H phase depends on the DH ratio. So very easy in that cell to increase the DH ratio to a threshold because the DH originally is higher. So we say that there is a communication between the membrane transport and the mitochondria, and in the healthy cells, they are balanced. But the mitochondria, which is damaged in the cancer cells, give a chance for the cell to enter more frequently to the H phase. How can we prove that the mitochondria production and this metabolic water has a key role? So we replaced the drinking water of the laying hens for 25 ppm deconcentration, and we started to collect the eggs. We separated the eggs, the yolk, from the white. We take out the water from the yolk and the white, and we burn back to water the yolk and the white, the dry yolk and the dry white. So what we can see then, when the laying hens started to drink DW with 25 ppm, the deconcentration of the water equally reduced in the white and the yolk. In the white, there was a decrease in the protein, but it was more significant in the yolk, which is finally lipids. So then we took a yolk and added to the food of the mice, which was transplanted with tumor, MCS7 breast cancer cell line, and we followed the survival of the mice. The control group perished relatively early. Those group of mice which has deuterium depleted yolk, they live longer, and those groups which even consume DW, they live even longer. So just simple changing the deconcentration of the mitochondria, which is burning, we could modify the length of the survival of these mice. So it means the diet strongly influences the chance to get cancer or not get. And I would say that the biggest problem in the society that there are 400 million diabetic patients and 19 million cancer patients, that it was said that the fat is bad. No, it is not true. Our population is living with a higher deconcentration than it was my grandfather who ate the bacon. And I guess we should go back and we reduce the average deconcentration with 10 ppm, and that way we would reduce the cancer incidence and then the metabolic disease. So what will happen with the genes when we modify the deconcentration? It is so-called nanostring technology, when we give a barcode each different genes, and we are able to count one by one how many messenger RNA was synthesized from a given gene. So the cells were growing on a 40 and 80 ppm, DDW media, 150 and 300 ppm. We could simultaneously investigate over 200 cancer-related genes and 500 kinase genes. And we agreed that we will examine only those genes where the changes in the expression over 30% and the copy number is over 30. This is what we see. So 77% of the cancer-related genes immediately responded when we changed the deconcentration. And out of that 155, the copy number was over 30. So finally we could investigate 124 cancer-related genes and 135 cancer genes. Theoretically, this is what we can see. No any response, one gene is downregulated, but doesn't matter the deuterium enriched media, or downregulated both, and vice versa, theoretically. But this is what we have. 99% of genes responded to the higher deconcentration. So here we had one gene which was upregulated in DW and upregulated in deuterium enriched media, 5 genes downregulated and upregulated, but typically 99% of the cancer-related genes responded to the higher deconcentration. And this is the same with the kinase genes. 100, except one, 134 responded to the higher D concentration. So think about that. This is what would be the summary. So when we use deuterium depleted water, we simultaneously will inhibit and influence the expression of hundreds of maybe thousands of genes. Because this is something similar to what we saw in the first presentation. So we know tremendous amount of signal system, and the big pharma, small pharma believe that they are targeting the mTOR, they are targeting the PNet, and one of them, that there will be a drug. Never. And we will have in the same situation if they continue with that type of research. When we use deuterium depleted water, we simultaneously modify each of the signal system, and we can inhibit it. Okay, so what will happen if we use deuterium depleted water? We run a double-blind phase 2 clinical trial with the prostate cancer patients. We evaluated 22 in the placebo and treated groups. Patients consumed for 4 months 85 ppm DW or for 4 months 150 ppm. Within 4 months, there was 80% decrease in the PSA level in the treated arm. It was only 47% in the placebo arm. In the treated arm, we could see 160 cube centimeter decrease in the prostate volume. It was measured by rectal ultrasound every month. It was only 54 in the placebo arm, which was very significant. The trial lasted only for 4 months, but we checked the survival after a year, and we found that we lost 2 people in the treated group and 9 in the placebo group. So it was clear that those who were consuming DW for 4 months, they live longer. To register cancer drug is not an easy job. First of all, need $1 billion, $2 billion to complete a drug. Unfortunately, we don't have it. So the only chance to survive was and to proceed. So we came out first. We registered the Vetera as an anti-cancer drug for veterinary use. So in Hungary, the vets using it for 24 years, and they are very satisfied. 50% of the dogs and cats, we can cure them. But as we were not able to complete clinical trials because of funding problems, we came out a product which is a drinking water. And we followed people who were consuming DW. When I evaluated the data, at that time we have over 2,000 cancer patients. The cumulative follow-up time was over 8,000 years. This is a bad news that the cumulative time between the diagnosis and the patient started to consume DW is over 3,500 years, which means most of them come to us in a late stage, advanced stage. These patients consumed DW for over 2,400 years, and we could even follow up after they stopped drinking DW. These population roughly covered the distribution was as it is typically in Hungary. Without any selection, when we checked the median survival time of these over 2,000 patients consuming DW, the median survival time was 11.1 years. In Hungary, the historical contour means 2.3 years, which means there was a 4-fold increase in the median survival time. Here's a Pearson correlation which clearly shows longer they drink, longer they live. And that 11.1 years median survival time means that in Hungary, we lost every year 33,000 patients because they have cancer. Once the DW would be part of the oncotherapy, we would be able to save 25,000 lives just because integrating DW into the existing therapy. Breast cancer. We published earlier a paper with over 232 breast cancer patients. Here again, the cumulative follow-up time is over 1,300 years. This is again a bad news. Most of them came back a couple of years later. They were diagnosed and they consumed that. We can say that patients in an early stage, the median survival time is about 6-8 months, 8 years. In an advanced stage is about 1-2 years. So without any selection, just check the median survival time of these over 200 breast cancer people, it is a 12.3 years, the median survival time, which means roughly double the survival. But this is the distribution staging at the diagnosis. So even when it was diagnosed, 74 patients already had distant metastases and only 158 were in a primary stage. In that case, separating and checking the median survival time, so for the advanced stage, we got 4.3 years median survival time, and for the primary group being there, it's a threefold increase, suggesting that how advantageous can be if we combine it. When we are talking about drugs, the dosage is critical. So we calculated a DD unit just to compare the different patients. So the dosage depends on the body weight, the deconcentration, and the volume the patients consume. This is an example. If somebody 60 kilogram drinking 1.6 liter, 65 ppm, the DD unit is 2.3. But if the patient is 8 kilogram drinking less than 1.6 and 1.05, the DD unit is 0.7. So we had 74 cancer patients, breast cancer patients. And in that 74 cancer patients, there was metastasis 135 organs. There were patients who had 5 different metastases. And we followed the patients one by one and checking what's going on with the metastasis. And we made 2 groups. Those where the DD unit was bigger than 1 and the bigger DD unit was smaller than 1. And in that case, we could say 70% of the patients we can get complete response, tumor has gone, or partial response. There was a big shrinkage in the tumor. If the DD unit was smaller than 1, then most of the patients, no change or progression of disease was found. Glioblastoma. We just recently published 55 patients with glioblastoma. We know how bad that type of cancer. The historical control is about 12, 14 months. In that case, we could measure 30 months, which is good. But when we made 2 groups of cancer patients, those groups who missed the DW, say received the radiotherapy and several weeks after started to consume DW, then the median survival time was only 25 months. Those, when the DW was combined with radiotherapy, then we increased up 47 months the median survival. And it's typical DW combining radiotherapy, extremely good combination, because DW trigger radicals, radiotherapy trigger radicals, this together trigger the apoptosis. This is the basis of this. And this is the reason don't give antioxidant to the patients who are consuming DW, because the antioxidants will catch the radicals, and that way you will help the cancer cells to survive the consumption of DW. Lung cancer. The lung cancer, here is an example we checked by gender. So for males is 41, and for females over 100. And we know this about 7 months or 12 months of median survival. And the females always respond better to the DW. I don't know why, but they respond much better independently of the tumor types. Here's again some Pearson correlation, prostate, lung, pancreatic, colorectal, breast. We have seen 60 different cancer, the DW effective, but not on the same way. Of course, we hate the pancreatic cancer. It is still a very, very bad cancer type, even using the DW. The big question is, can we cure cancer? The good point is that patients can be in remission, and everybody is happy. And we hear in the first presentation, and I am very bad when the surgeon said, okay, the tumor was removed, go home, be happy, no any problem. It's a lie. No, never. Because nobody can, first we heard in the morning that the cells are leaving the primary tumor, staying somewhere, and nobody can guarantee that we killed all of them. But let's see what can we do with those 204 cancer patients who were operated they were tumor-free and consumed DDW. So here the cumulative follow-up time was over 1,000 years. The good news that the average time between the diagnosis and start of DW is less than 1 year. So they didn't wait so long after they were operated and became tumor-free. They consumed over 500 years. We lost 13 people out of 204, and the cumulative time was over 1,000 years. What happened? 159 never relapsed. We lost 2 of them, not because cancer, it was 20 years after the cancer was diagnosed. And this is the other, here we lost 8 people. And what is the difference between the first and the third one? So those who stayed in remission, and I would say they are cured, they started to consume DW, have a break, even they were fine, they started to consume again, then have a break, and even they were fine, starting to consume again. They coming back for several years, drinking DW. Those 8 people, drinks, break, maybe come back or not, and the average time was 4.1 years later, they died. They didn't prevent the relapse. So what is the main rules? First, start DW consumption as soon as possible, close to the diagnosis. Replace all the daily water intake. Those who combine it, they just help the cancer to adapt to the lowering D level. The deconcentration can start with 85, 105 or 85, depending on the cancer type and staging. It is critical to change the D level. For the cancer, the challenging is the changing D level. They are able to adapt any kind of deconcentration if you give the time to adapt to the lowering D level. So change the D level and lower it with 20 ppm within 2-3 months. And I say, even everybody is happy because no detectable tumor with PET, CT, MRI, come back and repeat the DW cured. And even we believe that 125 and 105 should be good for healthy people because nobody knows whether we can reach the 1.2 millimeter of the group of cells, and that way we could select out the cells, our body. So going back again, a cell whether start to multiply or not, it depends on thousands of things. The way the cell can trigger the cell division, if they increase the DA ratio, that way simultaneously send the message, thousands of genes, all the molecules, all the enzymes, and if everything is fit, then the cell will start the multiplication. So applying DDW, we can target the key mechanism, because this is how the cells are organized. So the probability that the cells enters the H phase depends on how strong the induction is, but the real determinative is how firmly pushed the brake is, which means how low the deconcentration is. Everybody is focusing on trigger or not trigger, but our life depends on whether we live our life with cancer or without cancer, reduce the D level. Either go to ketogenic diet or ketogenic type diet, eat much more fat, or drink deuterium depleted water. So the final conclusion, we are talking about molecular biology. The pharma industry is going to find molecules. No molecules which is able to cure cancer, because all the molecules receiving the message from that submolecular level. And simultaneously the cells must harmonize billions of events at the same time. And this is how the cell can do that. The good news is, in Hungary, in English, in Chinese and Japan, everything is written down. So those who can read these languages, they can read it and they can learn it, what we have done and what should we do. I should acknowledge hundreds of people who supported our work in the last 30 years. Thank you for attention, and this is how you can meet me.
Ich habe Ihnen nicht so viel versprochen, dass Sie auf diesem Kongress sensationelle Sachen hören. Ich darf nur zusammenfassen für die, die ein bisschen sich schwer tun mit Englisch: Das Trinken von deuteriumreduziertem Wasser kann Krebs heilen. Zumindest die Metastasen zum Verschwinden bringen. Und vielleicht muss man dazu sagen, je älter wir werden, umso mehr haben wir Deuteriumwasser in uns, schweres Wasser in uns. Und dieses schwere Wasser hindert verschiedene biologische Prozesse in unserem Körper, vor allem was das ATP-Bilden anbelangt. Und wir haben ja vorher gehört, wie wichtig diese ATP-Bildung ist für ein gesundes Leben. Je älter wir werden, umso mehr schweres Wasser, Deuterium, schweres Wasser bilden wir im Körper. Dieses Deuterium-schwere Wasser wird ausgeschieden, indem wir Deuterium-reduziertes Wasser trinken. Das heißt, wir können Krebspatienten helfen, indem wir ihnen Deuterium-reduziertes Wasser zum Trinken geben, aber ausschließlich, nicht mischen mit normalem Wasser. Und man beginnt mit einer höheren Konzentration und geht dann immer weiter hinunter bis auf 85 ppm, von 150 angefangen. Die optimale Situation im Körper wäre 130 ppm von Deuterium Depleted Water. Man muss sich damit ein bisschen beschäftigen, aber man kann im Internet über Deuterium und die Bedeutung von Deuterium auf YouTube nachlesen, wie schwer das uns beeinflusst, wenn wir zu viel Deuteriumwasser in uns haben. Was er gesagt hat, ist auch wichtig, dass die fettreiche Kost wesentlich dazu beiträgt, dass wir weniger Deuteriumwasser haben. Also das ist sehr, sehr wichtig, weil es geht um Leinöl, es geht um Budwig-Diät, es geht um verschiedene Sachen, die sich dadurch bewahrheitet haben. Und die Zahlen, die Somlyai zeigt, die sind sensationell. Und ich kann nur sagen, aus eigener Erfahrung, Metastasen verschwinden. Und das bei jungen Menschen genauso wie bei älteren Menschen, wenn sie nur lang genug Deuterium Depleted Water, Deuterium reduziertes Wasser trinken. Ich möchte mich, I want to thank you, köszönöm szépen, so viel kann ich Ungarisch, for sponsoring. For sponsoring the water for a friend, yes, who had a reduction in metastases significantly and is improving a lot. And we will proceed with this procedure. Man kann nicht lang genug das Deuterium Depleted Water, und jeder von uns könnte es präventiv trinken. Also, so wie ich hier in der Runde sehe, sind alle schon in einer Altersgruppe, bis auf wenige Ausnahmen natürlich, ja, die durchaus anfangen sollten, Deuterium-reduziertes Wasser zu trinken, damit sie keinen Krebs entwickeln. Weil das ist wirklich eine der wenigen Möglichkeiten, nebenwirkungsfrei zu trinken, ohne dass man später Krebs entwickelt. Und ich glaube, aus Ungarn sind schon viele Sachen gekommen, die gut sind. Vitamin C, St. Georgi hat das entdeckt, Nobelpreis bekommen dafür. Semmelweis war, glaube ich, auch ungarischer Abstammung. Was? Ja. Habe ich recht, ja, ein bisschen was weiß ich noch aus der Geschichte. Ja. Den hat man auch verdammt, weil er gesagt hat, man soll sich die Hände waschen, bevor man zu den Patienten geht, wenn man von den Leichenobduktionen kommt. Er wurde ins Narrenhaus gesperrt. Ja. Ich hoffe nicht, dass uns das passiert, wenn wir heute über Deuterium Depleted Water sprechen, aber das ist eine Sensation, dieser Vortrag. Das ist eine Sensation, dass Sie eine Firma gegründet haben, die das Wasser herstellen kann in großer Menge. Ist auch nicht so einfach. Und ich glaube, wir müssen uns sehr bedanken für diesen Vortrag. Verstehen Sie ein bisschen Deutsch?
No, unfortunately not.
Ich verstehe nichts. Ja. Okay. Was?